Hello, and thank you for joining us. In this video, we'll be discussing how to look at a transformation of an exponential function and determine the equation from a graph. So here we have the graph of y equals f of x as a transformation of y equals 2 to the x. Determine an equation for f. Okay, well, if we know our parent function is y equals 2 to the x, we can start to figure out some information based on our basic understandings of the graph of 2 to the x. So we know that graph of 2 to the x looks a little something like that. It has a y-intercept of 1, right? And if x is equal to 1, we know the value of the function will be equal to 2. Okay, so very quickly from here we can see that we've had some transformations in terms of having a reflection over the x-axis and in terms of having a vertical translation where we moved upwards. Okay, we can also come over here and identify that we have a few places that we seem to intersect within our coordinate grid that could help us determine the equation that we're looking for. Okay, so we're going to say the following. We're going to say the following, that we know that f of x is going to be of the form some a times 2, and we may have some sort of x minus k, and then it does seem to be that then we move up by 4 units. Because of this reflection in the x-axis, we know that a is going to be less than 0, right? Now, we don't necessarily know about the horizontal translation yet, and we don't necessarily know about the vertical stretch or compression factor, but we do know what this reflection is, that a is less than 0. And we know that we've got this horizontal asymptote of y equals 4, so we have this plus 4 at the end. Okay, so let us then consider. Let's try and keep it simple. Let's say that a is just -1. All right. Well, what points do we have? We know that f of 0 is equal to 2. We know that f of -1 is equal to 1. We know that f of +1 is equal to 0, and it seems to be that f of 2 is equal to -4. So let's see how that might be able to help us determine what type of translations. We're going to try and keep it simple, right? We're going to try and keep it simple to start off with. So if we assume that we have had some sort of translation, well, if f of 0 is equal to 2, that's going to be equal to a times 2 to the -k plus 4. Okay, and if we consider what we have, that that's going to be equal to +2, then we want to be careful about what this k value here is. Maybe we don't have a k value, and in fact, if that k value is 0, right, if that k value is 0, then we might have a value for a, right? So let us consider that there is no horizontal translation. So let's consider k is 0. If k is 0, then f of 0 is going to be equal to a times 2 to the 0 plus 4, and that would imply that a is -2. Okay, let's see if that continues to help us. All right, so let's consider f of 1, and f of 1 is equal to 0. Let's assume that a is -2, so that's going to give us -2 times 2 to the x plus 4, but x is going to be 1, and so that would be -2 to the first power. And -2 times 2 to the first power is -4, plus 4, that's equal to 0. So that seems to work for us. Let's try with f of 2. f of 2 is equal to negative 4, and that'll be negative 2 times 2 squared plus 4, and that would be negative 8 plus 4, which is negative 4, and so that seems to work for us as well. So with our understanding of the basic form of the exponential function, then we're able to determine our equation. That means that the equation for f of x is equal to negative 2 times 2 to the x plus 4. Okay. Now, technically speaking, there's a number of ways that we could write this. That's why you see here that it's determine an equation, right? Determine an equation, because technically we could say that this is the same as negative 2 to the x plus 1 plus 4, right? That works for an equation. We could also say that this is equal to negative 2 times 2 to the x minus 2. That works as an equation as well for this. But we like to try and keep it simple so that we don't overcomplicate things. So we can say, hey, we have this reflection over the x-axis, we have a vertical stretch by a factor of 2, and we have a movement up by 4 units. But technically somebody else could say, well, I had it as a reflection over the x-axis, shift to the left by 1 unit, and then move up by 4 units. And either of those do represent the same thing, right? And the main reason for that is we know that 2 to the first power times 2 to the x is going to be 2 to the 1 plus x using our properties of exponents. Okay. Thank you very much for your time. Remember to ask questions as you need help.